Today we are going to learn how to extract objects out of a video. We will take, for example, this video, this dog sitting on a chair, and we will build a model to learn how to segment any dogs. On the right side you can see the results. It's in slow motion of the dog with a black background, and then we merge the dog with a new background. Lovely results. We will learn how to build this model based on YOLOv8, and we will train dogs' images. We will start with a simple image like this dog, and we will learn how to build a segmentation model based on YOLOv8 in order to create masks of any dog and then grab the dog out of the original image. So let's start. So before we start the segmentation tutorial, I would like to point out that this tutorial is part of a playlist that deals with the best image semantic segmentation. You can find here more tutorials. I'm explaining about more Python libraries like Decathlon 2 and Segment Anything and YOLOv8 and of course YOLOv8. You can click this link to see more tutorials. So let's continue. So let's start with our tutorial. We will first start with the installation part. I will leave a link for this instruction in the video description. As you can see, the first step is creating a conda environment based on Python 3.9. It can also work well with 3.8, but this tutorial was done with 3.9. Next, of course, we are activating this new environment, and then we should install several Python libraries, and it's very important to keep this order. First of all, we are installing Supervision, very good Python libraries that deal with computer vision. Then we are uninstalling, please notice, we are uninstalling OpenCV Python headless. Next, we have to install the PyTorch version. In order to do that, you should write this command prompt nvcc ---- version, and then you will discover what is your CUDA version. My CUDA version is 11.8. You should go to the PyTorch website, and here, before you're installing the last version, go to the previous version, and here you can see for each of CUDA environment what is the relevant PyTorch version that will be suitable for your CUDA version. For example, if I will look for 11.8, you can see that PyTorch 2.2.2 is a good version that is suitable to my CUDA, and 2.2.1 as well, and also 2.2.0. You can see that all these versions are suitable for 11.8. If, for example, you are using, just for example, 11.6, you can see that you should install earlier version, for example 1.13.1. So discover your CUDA version and then install the relevant PyTorch version. As I said earlier, mine is 11.8, so this is the command line for installing the relevant PyTorch version. You should copy it from the PyTorch website. Then we should install YOLOv8. In order to do that, pip install Ultralytics, and you should choose the right version. This tutorial was created using 8.1. Then once again, just to double check, I'm installing OpenCV and reinstall it back with this specific version. Please notice it should be upper version of 4.6.0. So this is the installation part. The next step is downloading the dataset. I have already built a dataset that contains images of dogs, and also I've done all the annotations. It's all polygon annotations and labeling and mask, and it's ready for you to download. See, this is the link for the dataset. This is basically a zip file. So after download the zip file, you should extract the zip file and copy the dataset to this local folder. You should create C dataset, dog segmentation, YOLOv8. You can create your own. For this tutorial, I chose this name for our dataset folder. So if you go to this folder, as you can see, we are here in dataset dog segmentation YOLOv8. You can see train and validation. Let's go for the train subfolder. As you can see, we have images, and there are lots of dog images. Let's open. This is one of the dog, another one, another one, another one. So these are the dog's images. And also we have labels, and in these labels that are based on YOLO format, we have these polygon dots that segment the dogs inside those images. So all the dataset is already done and is good for starting the training. So you can use this dataset for this tutorial. So now we are ready for the training process. We will use the YOLOv8 in order to use the pre-trained weights, and we will create first of all a fresh new Python file. Let's call it step number 3, and this Python code will generate our model and run all the training process. So let's start with importing the YOLO object out of the Ultralytics library, and we will create a main function. And first of all, let's load our weights. We will use the YOLOv8 M for medium, seg for segmentation. So basically we are creating an instance of the pre-trained model based on the YOLO8 model. Then we will create a folder for storing all the results of the training. It will be under the project folder, and then the experiment will be my model. We will store in this subfolder all the results. Batch size 16 means that each batch will contain 16 images, and the train function is the training process, and we will send several arguments. First of all, the config file. As you can see, the config file, the config YAML, contains a reference for the images and number of classes. We have only one class, which is a dog. So the data arguments contain the reference for our config YAML file. Second argument will be how many epochs, which are 100. Then the folder, the project folder for storing all the results. Also name will be the experiment subfolder under the project folder. Batch size 16. Device 0 means that we will use the first GPU found. Image size will be 640. This is the dimensions that YOLOv8 was trained. And let's also use patience 30, means that we will wait 30 epochs and for improvement. Val true means that we also run the validation data during the training. And now we will add another command for running this main function, and I believe we are ready. So let's run it. I will run it on a fast forward process. As you can see, this is the first epoch, the second epoch, the third epoch. You should follow the seg underscore loss values. As you can see, it's about 2.6, 2.3, 2.6, 2.3. I don't see any improvements. Let's wait a few more seconds and jump. As you can see, it's about 21 epochs and it stopped training. All the results are here. Let's open the results PNG. You can see that we have a lot of spikes on the trend seg loss. It's not a good result. Let's also open the val batch. I think it predicted pretty well. So since I'm not sure if the model was trained properly, let's run, let's write the prediction code, the test code, and let's see the results using one image. So we'll create a new Python file. Let's call it step number 4. This will be our fresh image. We would like to try to predict the mask or the segmented dog out of this image. So once again, we are loading the YOLO object. We will also use NumPy and OpenCV for image manipulation. The best.pt, this is the path for our trained model, our custom trained model. And let's also load our test image. So this is the path for our local image. Don't forget to change the direction of the slashes. It's important in some operation system. As always, the code will be, I will leave a link for the code in the video description. So let's load our image. And now let's load our model using our pre-trained weights. And let's run the prediction on our test image. It will store in the results variable. Now let's grab the class's name. Basically we have only one class, but just to figure out that the model has all the information, let's run it. Just a double check. As you can see, we have one class, 0 and dog. Now let's create an empty mask. It will be, empty, so all the mask will be based on zeros. It's like a black color. So this will be our final mask, and we are starting with an empty one. As you can see, it's a 0 mask with the same dimension as our image. Now let's grab the predicted class out of the results variable. So let's grab it using the results 0. It's on the first position. And we are loading all the predicted classes out of the results, and let's print it. Once again, we are expecting to see a dog. But as you can see, we have two masks. So the model can paint or show two masks out of our test image. That's interesting. Let's show those masks, or we can merge all these masks and grab the best one. So now we are running a for loop through all the predicted masks. And let's grab the first mask inside the loop. When we are multiplied by 255, that means that all the 0 values will stay 0 and all the other will become white values, since 255 is white. So once again, let's print all the discovered masks and classes inside our for loop. Let's run it. Once again, as you can see, we have two objects discovered by the prediction process. let's resize the mask to our test image. And now let's merge all the masks together to a one big mask. We will call it the final mask. So basically we will get the higher values, which are the white areas, and the final mask contain all the masks together. Let's also print each of the masks discovered in our local folder. So we will have two images, two masks in our folder. Let's choose to store it on the My Model folder. And also we would like to store the final mask as well in the same place. So we will have output 1, output 2 for each discoverable mask, and a final mask for our final mask. The next command is just to double check that all the values will be white or black. So we are using a threshold. So if we have a gray values, so it's a value between 0 and 255, we will change all the values to 0 or 255 using these thresholds. So every gray values under 128 will be black, and above it will be white. Next, we would like to change all the data types, all the value types to U integer 8. It's a preferable value for OpenCV, so we are using the AS type for this purpose. Now it's the important part. We would like to grab the region of interest out of our original image. So in order to do that, we will use the bitwise AND function of OpenCV, and this function will take our original image, put a mask on this original image, and get and extract our dog out of the original image. And now let's show our original image, let's show our final mask, and let's also display the results, which is extracting the dog out of the original image. This is our result image. And let's wait for a keystroke after displaying these three images. And I believe that now we are ready to run it. Let's see the results. So we have three images of the same dog, but as you can see, the ears were cut off. The mask is not good. I believe the problem is the training process. So let's retrain it with a minor change in the arguments. So after the last result, I decided to run the training again. So if I go back to this training Python file, I changed the patience to 40. I believe it was 30, so I changed to 40, so the training should wait 10 more epochs before it stop training as an early training process. And then I ran it again, and this is the result. As you can see, it ran all the 100 epochs, and the segmentation lost is better, is a lower value. So let's go to the new subfolder of my model. It is now named my model 2. So now let's go to my model 2. This is the new subfolder created after the second train. So let's open this subfolder. As you can see, we have my model, it is the first training, and my model 2, which is the second train. Let's open the results. As you can see here on the training segmentation loss, it's very good results, goes down during the training. And let's now run our previous program of segment one dog, and the only thing we have to change is here we would like to run my model 2, so it's here my model 2. We would like to get the best model out of the second training, and also during the saving we would like to save the mask here in my model 2 and also the final mask here in my model 2. And let's run it again. Let's wait a few more seconds. And now, as you can see, this is the original image of the dog. This is the result, and this is the mask. As you can see, now we have the ears. In the previous model, the segmentation was not good enough, but now the process ended perfectly. So let's go to the next step and try a prediction on a video. So we would like to extract a dog out of a video and then put the dog on another background and run it as a similar video. So we will extract an object out of one video and put it on another video. A very cool process. So this is our original video. As you can see, a dog sitting on a chair. And this would be our background image. We would like to extract the dog and put it on this image and run it on a different video. Very cool process. So we will start with importing the YOLO objects and also import NumPy and OpenCV. Let's add our path for this video. I will leave the images and the video along with the code so you can run it on your local machine. This is the path for our model, the same one that we retrained it earlier. And this is our background image. Let's also grab the path for this image. So we have the video, we have the model, and we have the background. Let's load the background image. We will use a simple imread function using OpenCV. And next we will open our video using the video capture function. And the next process, the next code will be checking if our video was opened successfully. If not, we will not continue to the next step. And the next step will be creating a while loop. And the only way to break this loop is going to finishing all the frames in the video or pressing a key, and we decided to use the Q key for breaking the loop. Now the read functions will read each frame in each while iteration. Now let's resize our frame. We would like that the inference process will be a fast process, so we are reducing the size of our frame by 30%. So this is the scale percent by 30. Now we are creating a dimension variable, and now we are resizing our frame. Now let's load our model with our custom weights. And now let's run the prediction on our reduced frame. So the results variable contains all the predictions, all the masks that were discovered during the inference prediction. Let's first of all grab the names of the categories. Basically we have only one, which is a dog. And now let's create two variables. One, let's call it our best mask, and the second one will be our best confidence. So what we are going to do, we will iterate through all the discovered masks and grab only the mask that has the highest confidence. So now we have the predicted class, and for each class we have the confidence values. This is the commands to extract it out of the result variable. And next we will run through all the masks using a for loop. Okay, we are grabbing the mask. We are doing a similar process to our previous tutorial. So we are grabbing the mask, grabbing the class ID, and we are also grabbing the confidence for our specific mask. Now we will resize the mask to our original image, and now we are checking if our confidence is the best one, the highest one that we discovered so far. If not, we will update our best mask and best confidence. So after looping through all the masks, we will have two variables, best mask and best confidence, that will have for this specific frame the best mask, and then we will use it to extract it out of the original video. Now we will change all the values to 0 or 255 by a threshold function. As previous tutorial, we will convert the data types to uinteger8, and now we are ready to extract the region of interest out of the original frame. So basically the process would be that for each frame grabbed from our video, we will run a prediction and a for loop to get the best mask. And now after the for loop, we will extract it out of the original frame, and then we will merge it with our background image. So the next 4 or 5 lines doing this merge process, we are looking for a specific place to store the dog inside, to place the dog inside the background image. We are looking for the center of the background, and then we are also looking for the dimensions or the position of the dog, and put them all together as a one merge image. And you can look at these 4 lines. We basically creating a final variable, which is the final image that contains the background along with the dog inside the background. And then since the result it's a little bit let's say a big image to display it, we will rescale it by 60%. So now we are finishing creating our final image, and I believe we forget to add a break for the loop. If the video ended, means if we arrive to our final frame, we would like to break the while loop. And after that, now we are ready to display all the results and all the frame and images. So the first one will be our original frame, the dog sitting on the chair. The next one will be the mask. We would like to display the mask. This is the result variable. And the last one is the final image, which contains the background and the dog as one image. And let's also add this wait key, and if we press the Q button, we will break the loop as well. And that's it. Now we are releasing the original video, and we also releasing all the videos that are opened. I have some syntax error. Let's fix it before running. Interpolation, okay, and also here it should be mask. Okay, fix it as well. Else, anything else? Thresh binary. Okay. Now let's run it. Let's wait a few more seconds. Great. So this is the final image, which is the final video. On the left side is the original image, and on the right side is the mask that being predicted during running all the frames. I hope you enjoyed this tutorial. Thank you very much. Hope to see you on the next video. Bye bye.